All right, good morning, and quick reminders about what's going to happen. So let's take a look over here. All right, so your programming test number 1 will be tomorrow. Just make sure the same rules. I'm going to send you some reminder later this afternoon. And for the programming test 1 review session taking place on Sunday, the materials have been there. Just in case you haven't seen that, let me show you very quickly. So you can go to the lecture site. Let me refresh the browser and show it to you. Give me a moment. There we go. All right, so if you go to the lectures page, and then you will be towards the end. All right, so you will be around here. Review session, right? You can see that, programming test 1. So you got different options over here. So you can see, you got different options here. If you really want to go over with me about developing the practice test 1 solution from the beginning until the end, you can follow through the recording. That's one option. If you just want to look at what the final solution is look like compared with your solution, you can also download the source code. That's also made available to you. Choose the one you want. Well, if you want to look at both together, that's also okay. Everything is made available to you. And if you want to look at, there's also one thing I want to mention. If you go there, the iPad notes, on one pages, I wrote down some tips for you guys to really consider, just to be more efficient, given the time constraint that we give to you. So this is really about around 15 minutes or so before your test session ends. You really want to start getting rid of all the compilation errors. All right, that's something I'll leave to you. Think about it and really want to consider, kind of plan ahead how you're going to deal with those kind of errors. And there should be no surprise about the kind of methods that you have to write during the programming test. Everything has been covered already in the learning materials. But you will just have to be efficient during the test session. All right? All right, do you guys have any questions in general that you want to ask me before I move on? Alrighty, let's now talk about the materials. And then, if you got any other questions, I still got office hour today, 3 p.m. More than happy to see you there if you need help. Okay, so let's have a quick recap about what we talked about last Thursday. So today we can finish about the JUnit testing, and then we can talk about some fun stuff, object equality. That's actually quite an interesting topic. That will be the second half. One thing at a time. Quick recap for last Thursday. So for last Thursday, we started talking about basically how you can do JUnit testing. I would say it's a very smart but very practical lecture, just about applying exceptions, normal flow versus abnormal flow, and also how you can derive test cases, and also how you can test for if exception is expected versus testing when the exception is not expected. Right? We're going to talk about more examples today. Right, try and catch, the catch or specify principle. And this is just a small example of developing some test strategy for your application. If you also want to dig in a little bit further, you can speak to me also during the office hour. We can look at maybe some more complicated example. But I think for the lecture, this example here will be good enough. And then we got counter, right? We got 2 possible exceptions. And this page over here is very important for you to understand, right? Whenever you're trying to write a JUnit test method, or you're given one, depending on what the expected output is, also depending on what the actual output is that's produced by the method under test, you want to see whether or not they match. So here are 2 possible cases that we're going to talk about. What we talked about last time, if the expected output is no exception should be thrown, but the actual output throws some exception, in that case, it will be a failure. Option number 1. But let's say if the expected output is, we do expect to see some exception to happen in the invalid input. But somehow the output didn't throw that exception. It will still be considered as a failure. Right? So these are the different combinations you want to get comfortable with. We got all the combinations explained in the examples I provide in the lecture. But we're going to see more today. You just want to make sure this flow here is very clear in your mind. And regression testing, you can definitely revisit the recording if you got any doubts about the procedure. I think it's definitely more valuable when you actually got a red bar from the JUnit, in which case it tells you the last change you made may have introduced some error. You want to pause your developments right away, go back there and fix it. Right? That's really the right mindset to have. And we talk about the basic of JUnit tests. You just want to remember it is important to note, whenever we consider a test case to really a success, what does it really mean? That means you don't really have any assertion failure. And also, there's no unexpected exception occurring. So these are the two conditions. If neither of them occurs, your test will be considered success. That's why we said, if you simply leave the test empty, it's going to pass automatically. Passing test, but not very useful. All right? So let's now go on. Okay, so this was the last example that we talked about. Let's now recap that one, and then we move on to the next one. In this example here, let's take a look at how the test has been set up over here. Let me remind you, we have a counter. It has the minimum value 0 initialized, and we want to make sure the value never go above maximum value, which is 3. So it can be 0, can be 1, can be 2, can be 3, but cannot be 4. So the way we set up the test is like this. When we try to do the first increment, at this point, c dot value is simply 0. At that point, if we try to say increments over here, we should not expect any exception to be thrown. That's the expectation. So that is why if we are able to go from this line here to this line, it will be considered as normal flow because no exception has been thrown. In that case, we simply make sure the value has been incremented from 0 to 1. Otherwise, if some exception unexpectedly simply disrupted the execution flow all the way to catch, meaning that this will be bypassed. In that way, if we got this exception here that's unexpected, we should fail the test unconditionally, right? So this is a very sharp application of the normal versus abnormal flows that can be caused by exception, either occurring or not occurring. So I want you to really be clear about how the things has been set up. Just before I take a question here, when we see the second example, or in this first example here, we expect no exception to happen. But in the next example, it will be the opposite. So that's something you want to watch out, how the structure of the test has been set up. Question?
How to make sure make sure the actual value or not? The expected value is correct.
Sure. So here there are two expectations you can think about. So in this particular test, expectation number 1. After calling increments when the c dot value is 0, expectation number 1, no exception should be thrown. Exception number 2, if we are able to get to here, this line, that means no exception has been thrown. That's good. But expectation number 2, we want to make sure the new value for c counter has become 1 rather than initial value 0. So two things. So increment here, for the correctness of it, should do two things. Number 1, it should increment the value from 0 to 1. Number 2, it should not trigger any exception to be thrown. Two things. So this test is doing both. Okay. And last time we also kind of trace either the implementation you're given to test is actually correct versus if the implementation is actually not correct, right? We talk about different execution flow. So that's really the stuff you want to review, right? That's the example number 1. All right, guys, any question about example number 1? All right, let's now try to reinforce the idea a bit more. Let's consider the second test case. So the second test case looks like this. Let's take a deep look. So this will be some comparison you will have to do. I would suggest either you can load the 2 pages on your tablet or simply print them out. I want you to print out this test and the previous test that we had. Compare them side by side. You will see that the way we put the fail assertion is in the opposite place. You can now see the fail is here as opposed to in the catch block. There's a reason, because now our expectation is different. Let's take a look. So the name of the test we're testing for decrements when the minimum value is the case for the counter. So we should not allow it to go from 0 down to -1, right? We got an initial counter here, and then we try to assert its initial value is simply minimum, the same as before. But now, let's now try to take a look at this. This method over here, we are trying to decrement when c dot value is actually equal to 0. That should not be allowed. So our expectation goes like this. The value to small exception should occur to signal this error here, because we are trying to decrement the counter when the value is already the minimum. Okay? So this is why you can see the way flows will work goes like this. If the exception occurred as expected, sorry, let me say that again. If the exception happened as expected, we'll go to the catch block. In that case, we're going to get value to sworn exception and we'll do nothing. That means we don't really fail the test. In other words, it will pass. All right? So this will be option number 1. The exception, the value to small exception occur as expected. In that case, we're going to pass the test. And by passing the test, we simply do nothing. That's good. On the other hand, if we go for the alternative flow, let's say we go from here and go to here. That means the exception did not occur. That's why we can go to the next line. Expected value to small exception did not occur. In that way, we're going to fail. And the way we fail the test is just to say fail unconditionally. So you really want to compare and contrast how this test and the example number 1 test has been set up. It really depends on what the expectation is. Okay? All right, any question here before we do some tracing? We good?
So in case of the error happens, that means the logic when you write the method is...
Yes, maybe wrong. That's correct. So we'll see that for sure. So the question was, how can this actually happen? So we really expect the exception to occur, but somehow it did not occur. How is that possible? So we'll see. So somehow the hidden implementation, you as a tester, in general, you don't really have any knowledge about what's given to you. So you're just testing it by setting up the structure of the test properly. If somehow you're given the right implementation, good, you will simply just catch that expected exception and pass the test. But if you're given some wrong implementation, which would not throw that exception, in that way you're going to fail. To tell your maybe teammate to say, you're wrong. You're supposed to throw the exception, but it did not occur. Okay. All right, let's now trace the 2 cases over here very carefully. All right. And after this second example, you got actually both cases covered. Either exception is expected or not expected. Okay. Sorry. Somehow my iPad is a bit slow. Give me a moment. Let me do it again. Sorry about that. I may just have to reload. There we go. Okay, now let's now trace this case. We're going to consider 2 traces. Either the implementation is correct, meaning that the decrement has been programmed correctly, especially the condition here is right. This is correct. Versus, we're going to have a different version of the decrement, in which case we're going to, let's say, modify this equals here, and then we're going to say, rather than equal, why don't we say less than? So this will be the wrong implementation. We're going to run the same test on 2 different implementations and see how the test is going to accept one, but going to reject the other, right? The first one. Let's say we're given the correct implementation over here, and remember the correct implementation means it's going to throw the exception when you try to decrement the counter. So let's now trace it. All right, number 1 here, create a counter. And then we're going to assert that to make sure the minimum value is the initial value for counter. That one is good. And then number 3, go into the try block. Number 4, we try to call C dot decrements. At this point, C dot value is equal to 0. All right? And we're going to step into C dot decrements. So we're going to step into here. So number 5, check the if condition. And now we're going to get C dot value will be 0. Minimum value is 0. 0 equal to 0. True. So we're going to throw that exception as expected. So this is why this is correct implementation. Number 6. And then we're going to bypass the else. All right? So now after line number 4, where should we go, right? Because the exception did occur, we're going to bypass the fail. And then we're going to go into the catch. So that will be number 7. And then you can think about conceptually number 8 because it's simply nothing to happen, in which case the test is going to pass. What's really interesting here goes like this. The way we trace the code over here. And I make a remark. This one here is what we call, when we talk about exceptions, this is called the abnormal flow. However, due to the expectation we have, the abnormal flow implies a pass. So you really want to get through your mind why abnormal is going to mean pass in this case. All right, that's the critical point when you study. All right. Any question about this first trace here? Yes. That'll be another issue, of course. In that way. So the question was, what if the counter was initialized to be, let's say, -1? Okay, then we would have failed the test earlier in this way. So let's say, of course, that one wouldn't be the job for the decrement. It would be the constructor's job, right? So let's say this. When you first create this counter over here, new counter, let's say, is now going to set it to be -1 incorrectly. And for the next assert equals minimum value 0, value -1, you're going to fail that right away. So you'll be a fail, which is still good. Good question. All right, the next trace will be the same test, but a wrong implementation. So I simply modify the sign over here. All right, let's now take a look. We're going to trace the same test. Number 1, right? Number 2, and it's going to be 0 versus 0. Good. And the try block, and then we try to call decrements. At this point, C dot value will just be 0. And then we're going to step into C dot decrements. So we're going to go here. It will be number 5. C value will be 0. Counter value, the minimum value will be 0. 0 less than 0, false. Bypass. So we don't throw that exception as expected. And then we're going to go to the else. And then we're going to decrement the value. Basically, after this, the value will be from 0 down to -1. Wrong, right? And then now, when we, at the end of this method call, should we go to the next line or should we go to the catch block? Next line, right? Because no exception has been thrown. So this will be number 8. Number 8. And then after that, bypass the rest. Now, the remark to make is we are experiencing some normal flow because no exception has been thrown, but the test failed. All right? So here, the thing for you to realize is we have some normal flow. However, the test fails. But everything is logical, right? You want to think about two things independently. One is normal flow, abnormal flow depends on whether or not exception has occurred. Pass or fail depends on if you expect the exception to occur or not. It's a different issue. All right, any question here? All right, so far we talked about 2 test cases. In one, exception is not expected. In the other one, exception would be expected. Now I'm going to show you another example here where exception might be expected at some point, but may not be expected at some other point. It's also possible. All right, that's more interesting. But it's not too bad. The same principle we're going to see. All right, so now let's move on to the next one. That's also on the slides. What we want to test goes like this. If you remember conceptually, right? Let's say we know that the counter values start to be 0. And then if we do increment for the first time, it should go to 1. If we do increment the second time, it should go to 2. If we go for increment the third time, it should go to 3. So far, no exception is expected, right? But if we try to do increment one more time, this is where our expectation flips. In that case, the expectation will be exception should occur. So now the single test is going to divide this idea to be two parts. So we're going to have the first part here where the expectation is exception should not occur. This will be the second part where the exception is expected to occur. Two phases. Okay, I'm going to annotate that in here so you can compare. This will be the first part. Versus this is the second part. Okay, the first part over here, the value 2 large exception not expected because we're still incrementing the value from 0 to 1, 1 to 2, 2 to 3. Not expected. Versus over here, the value too large exception expected. All right, so you got to remember these two phases occur in the same test. So that's why the way you encode the logic about where to fail will be flipped, exactly the opposite. So this example here nicely summarizes the previous two examples. Okay, let's take a look. And then we're going to trace it all together. So the way it's going to work is like this. Initialize the counter. The value should just be 0. Increment the first time, 0 to 1. Increment the second time, 1 to 2. Increment the third time, 2 to 3. So far, no exception should be expected. If anything, if this exception really occurs unexpectedly, we're going to be disrupted to here that we're going to fail. Right? So this is like an example number 1. And then after that, we should really make sure the value has been incremented all the way to 3. After the 3 increments. That will be phase number 1. For phase number 2, at this point here, right before phase number 2, C dot value will just be equal to 3. And then we are trying to increment once more. That should cause an exception to be thrown. In which case, it is not thrown. So we move to the next line. In that way, we failed the test because what I expect to really happen as an exception did not occur. If I call this increment here, and then I really got the exception I expected, that's good. So I'm going to do nothing, so I pass the test. Right? So the single test really encodes two different logic, one phase after the other. Right? Any question about this conceptually before we do some detailed tracing? Yes? The first one? Okay, let's take a look. The first one, yes, it is possible to bypass the catch block. Let's say you do increment, you do increment, you do increment, and nothing unexpected has happened, which means we don't have any exception. In that way, of course, you got to bypass the catch block, and then go ahead and assert the equals to be 3. That will be 1. That's assuming that the implementation is correct. All right, so now let's try to trace 3 different cases. Case number 1. Let's say the implementation is 100% correct, in which case we can go all the way down to the end, and then nothing bad will happen. The test will just pass. Example number 2. Let's say somehow the implementation is wrong. It is wrong because it did not really it is wrong because reason 1, it throws the exception unexpectedly. So you're going to fail this way. That's reason 1. Another one, reason 2. Maybe we can survive after here, but somehow it did not throw that exception as expected. We're going to fail that for another reason. So there are 2 possible reasons you can fail this test, either because of this or because of that. We're going to see both. But when you want to pass, you want to make sure you don't really fall into the fail, either one. All right? Let's now take a look at case by case, and it'll be more clear. But the overall picture is you have to understand how to set up the input value so that you can exercise different parts of the code. That's the main goal for this lesson here. All right, let's now try one by one. Okay? Now, case number 1. What if the implementation is 100% correct? All right, so we still got this equal here. That's correct. So let's try that. So start with this, initialize the counter, go to the first try block, and then number 3. Okay? So here you can imagine that we're going to step into increment 1, 2, and 3 times. All right, let me do a little bit more efficiently. If we try to go there 3 times, let's say if we go here, the value at the first time is going to be 0. And then 0 equals 0 over here. Would that be true or false? Let me see this one here. Am I value to increment here? Yeah, sorry, I got myself confused. That's maximum value. That cannot be minimum value. But if you change it to minimum value, that'd be a wrong implementation. Sorry about that. I was kind of worried that I might just make a typo. No. Let me do it again. Sorry about that. So when you try to do increment 3 times, the first time, value will be currently 0. The maximum value is 3. Right? Now 0 equals 3 is going to be false. So we don't really go into this. And then we're going to increment the value plus plus. So that'll be from 0 to 1. The second time we call the increments 1 equals 3, false. So we still bypass that the second time. And plus plus is going to increment from 1 to 2. Now the third call for increments, 2 equals 3, also going to be false. So we bypass this the third time. And then increment this from 2 to 3. So far so good? So at the end of the third call to the increments, see that value is equal to 3. And so far, no exception has been thrown unexpectedly. All right? And since no exception has been thrown, so we are just going to reach the end of the try block right away. So we're going to bypass the catch block. So we bypass this first fail. So far, we're good. So that's why we don't fail the test just yet. So we're going to go for the next one. Let me just say number 4 here. And we're going to assert equals. Counter value should be, maximum value is 3, and then the counter value as we trace, it should be 3. So that one's going to pass, which is good. And then we're going to go to the second try and catch block, number 5. And then we're going to go for number 6. This will be the 4th increment. Now, when we try that, let me use a different color here. Number 6. All right? And then for number 6, we're going to do this. And now the value for the counter will be 3. 3 equals 3, true. And this time, we're going to throw that exception here, bypass the else. All right? So this will be, you can think about this in number 7. Right? Throw that exception. And since we're throwing the exception, we're going to bypass. So you can think about over here, throws the value to large exception as expected. In that way, we're going to bypass because it's an abnormal flow. And then we're going to go to the catch block and then simply do nothing. So we'll pass the test. So this will be a pass. So the tracing is slightly more complicated, but it's not too bad. I think that this will be a very nice exercise for you to really try to practice. It does exercise 2 different try and catch blocks, which has the opposite logic. All right? All right, any question about this? And the mistake I made in the beginning, let's say, for example, if I change this one here rather than maximum, what if I change that to be the minimum value? That would be your exercise. Now, how is the test going to accept or reject the implementation? Right? That'll be exercise for you. Okay? Any follow-up you want to ask about this? We still got 2 traces to be done. So if you're kind of getting it, hopefully it'll be even better after the next 2. So in this case, the implementation is 100% correct. Let's now inject some error. Okay, error number 1. Let's say for the increments here, we got less than. which we saw before, but let's give it a try. And now we expect the test to really fail because the implementation is wrong. But how is that going to reject the test? Let's now try that. So we're going to go for 1, initialize the counter, enter the first try block. And number 3, we try to see the increments. At this point, we expect C dot value will just be 0. And we're going to try see the increment for the first time. And then when we go over here, right, it's going to be number 4. Let's check the if condition. Value will be 0. Maximum value over here should be 3. 0 less than 3. True. We are throwing this exception unexpectedly. This will be number 5. Unexpected or wrong. All right, so after this, when we go back to over here, so at the end of this method call, so now where should we go? Should we proceed to the second increment? Not really, right? Because this is an exception. What we should do is we should go for number, so this part over here will be bypassed. And we just go for number 4, which will be the catch block, which is going to catch that exception. And then it's unexpected, so we're going to fail. And that'll be it. Once we fail, the rest of the test case will just be bypassed. You don't continue anymore. Once you fail, you just fail. All right? So the last line will be just this fail over here. So this actually tells you that, so this will be a fail, which is good because the test rejects a wrong implementation. Now we should really appreciate how the test has been structured because it can really reject something that's wrong. Okay, that's error number 1. You can see the way we failed this test is pretty early, just around this first phase, when we don't really expect any exception to be occur. But let's see another error where it might be okay for the first phase. Nothing unexpected has happened in the first 3 increments. But now, in the 4th increment, there might be an error. That's something we're going to see. All right? Now let's consider another wrong implementation. Okay? Now I'm going to modify this and make it over here. Let's say this one here, I would say larger than. All right? Larger than here. That's also wrong. All right? Let's see what's going to happen. That's wrong, so we really expect the test to reject once more. Let's now see. So number 1 here, number 2 here, and then number 3 here. I'm going to do a little bit more efficiently. We're going to do increment 1, 2, and 3. Right? So now imagine that we're going to execute this one 3 times. In the beginning, value will just be 0. Larger than the maximum value, false. So we don't throw that exception. And then it got incremented once, 0 to 1. 1 larger than 3, also false. So we don't really execute that. And then we got to increment another time, so from 1 to 2. And then 2 larger than 3, this will be the third call of increment. 2 larger than 3, also false. In which case, bypass this and then try to increment the third time. And then from 2 to 3. So this will be the final value at the end. Over here, C dot value will just be equal to 3. So far, everything works as expected. So no exception has been thrown, so we bypass the first catch block. And now, because nothing unexpected has happened just yet, so we go on to this one here, the next line. So this line here will be, let's say, number 4. All right, so maximum value is 3. C dot get value, as we explained, it will just be 3. All right, so number 5 will be the try block. Number 6 will be the 4th increment. Now this time, we do expect the exception to really occur. Right? Now our expectation just flipped. So for number 6, at this point, we know C dot value is equal to 3. And now we go here again. Let me use a different color here. So let's say C dot value equal to 3, and we try to call this the 4th time. So now let's try that. So now the value of the counter is 3. 3 larger than 3. False. So that means we still bypass this guy here. But that's not good, because now we do expect the exception to occur. And then we still increment the counter from 3 to 4. Something very wrong. We already go above the maximum. So nothing, so here, the value too large exception did not occur as expected. That means it did not occur, so we go for the normal flow, so we go to the next line. So this will be number 7. All right, so after we failed the test, we just failed. We don't really go any further. So you can think about this one here, it just bypassed. So now the test fails because the value too large exception actually occur. Right? Oh, beg your pardon, did not occur. The conclusion was wrong. The value too large exception did not occur as expected in the second phase. Right, if you see the overall structure about my setup over here, you just need some time to, again, dive into the code. The same piece of code for the test is executed on 3 different implementations. Completely right, something wrong, or something else wrong. You're going to see how the execution flow is going to go like. So the test is always going to accept if the implementation is right. It's going to reject if it is wrong. Right? The principle is simple. All right, any question here? Anyone? Okay, I presume it's not too confusing. If it is, you want to dive into the code and let me know how I can help. All right, so now we are done with case number 1 and also case number 2 and also test case number 3, right? We are done with all these 3, especially for test case number 3. That one's slightly more complicated. Got 2 phases with the expectation flipped. And let's now have some exercise together. It'll be a little bit challenging, but I think it's doable for you guys. The exercise goes like this, the first one. Let me just go back to the clean one. Now, we think about this phase, right? We think about this test, right? The one we just talked about. You can see we say we got 2 phases, phase number 1 and also phase number 2. Now, question for you. Rather than using the fail assertion, which is going to fail the test unconditionally, what if I replace the fail by maybe system.out.println line and then print out some error message over here? That's something I would like to discuss briefly, all right? Because that's something you should never do. Right? You should really not try to say, oh, if I fail the test, can I just print out something that's wrong in the console? No, you shouldn't do that. But let's see how wrong it is. I want you to stare at this piece of code over here for just a moment. And you can see that over here, where we used to say fail, but now they have been replaced by just system.out.println line. This line here. Oh, sorry, not this one here. This one here. And also this one here, the 2 star. Of course, there are other messages to say things actually work, but let's focus on these 2 lines, 1 and 2. Okay, take a look at the test over here. It's a console tester, I call, because we don't have any JUnits in play. Now we want to see how bad it is. Okay, just stare at that for just one moment. At least you can see what the structure is. And we want to discuss about why it would be bad. I do have some hints for you to really help you think, but before that, I wonder if any one of you may want to share your thoughts. Why would you think using console tester, system.out.println line, is a bad idea, as opposed to the fail assertion? Before I give you the hints. Okay, if that's too hard, that's okay. Why don't we see the hints? That might help. Here's the hints. The hints goes like this. Let's assume a scenario where we can show the test is actually bad. This is a scenario. Let's say the increments over here is wrong. It's wrong in the sense that it's going to unexpectedly throws a value too large exception in either this one here, or this one here, unexpectedly. That's the wrong implementation. Now, I want you to think about, let's say if the wrong implementation really got passed for us to test using the console tester. What's the consequence of running a console tester here versus using a JUnit tester? What would be the difference? That could be the hints for you guys. Okay, how about, yeah, give it a try. Which is not good, right? Why is that not good? You just stop and break the flow right away, right? That's pretty perfect answer. I like it. Yeah, good. So what your classmate just said was 100% correct. The idea would be, let's say this. Let's say somehow when I was executing this, right? Let's say hypothetically. When I try to execute this second increments, so let's say the value too large exception thrown unexpectedly. Let's say. In that way, we're going to go into, we're going to get disrupted. So we go bypass the rest, and we'll simply go here to the catch block, right? That catch block is going to print out something, error, rather than fail. All right, think about the flow. After printing out something to the console, if I say fail over here, like a previous, it's going to fail the test right away. But we don't do that right now, because this is only print line, which is not going to stop your execution flow. So we still go on to the try block and continue. That's the problem. All right? I'm going to write it down. Printing out an error about test failing will not stop the execution flow. That's a problem, right? So it's a similar argument when we talk about why you should really use exceptions as opposed to console error printout. And here, similar. Why should we use the JUnit assertions as opposed to printout? Because you want the flow to be somehow disrupted right away to signal the error. Yeah?
So that means the flow would be normal even though the implementation is wrong.
That's exactly right. So the remark would be, so here, what's really wrong here is, even though we know that conceptually there is a test error, as you can see from the contents of the printout. There's an error for the test, but the test don't really fail right away. You'll still continue. That's the problem. Yeah?
What if we had like a link value, if we had if statement, and I said example, let's say equals 0, and it doesn't mean that condition skips the
Yeah, of course, you can try to restructure your test in a way. Maybe that's going to deal with this case more properly. But still, in some way, you're kind of maybe writing some unnecessarily complicated logic, which would be simplified if you just use JUnit assertions. Yeah, that would be another argument. Yes, that's good thought. All right, any other question? Yeah, go ahead. Yeah, exactly. So I would say this is simply just wrong because somehow you can try to keep tracing. Let's say after printing out this error over here, and we still try to do increments over here. So somehow the counter value is already illegal, right? So somehow you can just trace the value, and then we're still going to print out maybe either error or maybe some success. So you're just simply just going to get mixed messages to the console. That's why it's wrong. I would say as an exercise, you can keep on tracing and see what's going to happen, which line is going to be printed out. All right? Exercise. Keep tracing and see which message printed. For example, it could be that this one is already printed, but we print another one, like two errors. Or it could be that this one already printed, we print to say success. That's even bad, even worse, right? yeah, in some way, it's, to be honest, this is not even a test. It's just like a main method. So I'm just trying to simulate what we did in the JUnit test. So somehow it also proves like how bad without using JUnit test, just using console tester just to have some printout messages. Yeah, that's the main point. All right, guys, we okay? Okay, one more exercise for us to think about, right? To struggle a little bit, but that's okay, also help us get more insight. All right, so now let's go back to JUnit assertion. All right, this will be a more interesting one to see because we don't have to deal with printout. All right, now I want you to compare this. What I used to have looks like this. Let's say I really don't like having two try and catch block. I just don't like it. I want to have a single one. What I'm going to do is I'm going to somehow move this guy here, maybe just to be part of the first try block, and get rid of the second try and catch block. I want to simplify my code, if possible. All right, so this will be, so you can later on compare this one here and the exercise we're doing right now. Take a look at this one here. A single try and catch block. And then we got increment here. We got increment over here. All right. Number one, is this test correct? I can tell you it's not. All right. This is no longer an appropriate test. But number two, why? Why it's not appropriate anymore? Think about it, and then I can also give you some hints. The hints goes a little bit like this. All right. Number one, you should really see the structural difference, right? Now we only got a single try and catch block. So now the question is, let's say we somehow execute line by line, and somehow we got into the catch block because some exception has been thrown. Now, do we know if this exception here is really expected or not expected? Do we really know? Because from before, let's take a look. From before, let's say this guy here, if the exception occur in the first phase, we know that it's unacceptable. But if the exception occur in the second phase, we know that it's acceptable, right? It depends. But now, if we only have a single try and catch block, do we really know whether or not this part here should be acceptable or not acceptable? That's the insight you want to get into this exercise, right? I basically already tell you the answer, but that's okay. I think this one here does require some thinking, right? So I'm going to reveal the hints over here. Right? That's exactly what I just said here. I'm going to write it down. You can think about it more. So now let's say over here. Is a value too large exception here expected or not expected? We don't really know. Because that value too large exception can be from here. The value too large exception can be from here, in which case it's unexpected. Or the value too large exception could be from here, in which case it is expected. Value too large exception can be from here, in which case it is expected. But if either way, they are simply going to the catch block, the same catch block. So we don't really know which case it is. So that's why we need two try and catch blocks. All right. All right, any question about this one here? Yes?
So in this case, we will always get the value, the exception.
Yeah, exactly. So now, if you somehow got some exception either from phase number one or from phase number two, they will just break the flow and go to the catch block. But the problem is when you get to here, you don't really know whether you should say fail or not. Because if that's actually from here, you should fail. If that's actually from here, you should say not fail. But you don't know because you don't have that information anymore. Yeah. So what's the lesson here? That means you don't necessarily have to always minimize the try and catch block. You just need to put however many you need logically. All right. Yeah, think about it. It's not that straightforward. Maybe for the first time you get exposed to it, but it takes some time. All right, I got one more example, and then that'll be it for this lecture, and we can take a very short break. All right. So on the slides, exercise number 1 that we did, exercise number 2. And this will be one more. This one is not really exercise, just to show to you, you can include loops in your JUnit test if you're interested in using it. All right, I'll show you very quickly. All right. So this will be some test case to really show to you how you can use a for loop. For example, you can see we got some for loop over here. Also, we got some for loop over here. And then this is a test method. We say test increment and decrements from the middle values. Right? What is it doing? We have some counter value, initially 0. And then we say that we simply just want to set some loop counter I. So I here is going to start from minimum value 0 all the way to the maximum value -1. So that will be 2. So I is going to be 0, 1, and 2. So it's going to execute 3 times. All right, so that means we're going to call increment 3 times. So this is basically what we did earlier. So by using a loop, you don't really have to say c.increment 3 times. Of course, in this case, you might end up writing more lines of code if there's only 3. But imagine that what if the maximum value is 1,000? In that case, you don't really need to write out c.increment 1,000 times. Using a loop is going to help you. Right? So that's the main point. So basically, at the end of each iteration, you're going to make sure the value has been incremented by 1. Right? So that's one assertion to make sure. I don't have any exception. If there has been any exception that's been thrown from this one here, you're going to go into either this exception unexpected or this exception unexpected. Both of them are going to fail. Right? You can take a look. What about the second loop? Doing something similar. We are basically saying we start from the maximum value, which is 3, all the way down to the minimum value over here, right? Larger than that. So you're going to be 3, 2, and 1. Again, we're going to execute it 3 times for the loop. So we're going to call decrement 3 times, call increment 3 times, and call decrement 3 times. That's what we're doing. And then at the end, we're going to at the end of each loop, we're going to make sure the result has been decremented, right? And then if there's anything unexpected occur, either this or this, we also try to fail the test. So think about this. Think about this catch block is if any of the increments or decrements throws value too large exception or value too small exception unexpectedly fail. And what we are testing over here is, if you think about 0, 1, 2, and 3, right? We try to do 3 increments followed by another 3 decrements. That's what we're doing. But you can see that we don't really have to explicitly write out increment 3 times and decrement 3 times. We're just using a loop to help us automate the process. Right? So that's the value for this test. And of course, again, the minimum and maximum are rather small in this example. So you may be better off just write them out explicitly. But I'm saying in general, the counter maximum minimum might be much larger, maybe from -100 to +1,000,000, in which case you have to use some loop to help you rather than writing them out explicitly yourself. All right, so for this example here, I would say, again, study the code very carefully about how things work. But I already explained to you the trickiest part about the bounds for the loop counter, and also this part over here to see why we should really fail the test for either reason. All right? Question? Sorry, which line are you talking about? You mean just the max value in general? Yeah, you can change to any line 10 here. Oh, it's different. Oh, remember we're doing minus, minus. Yeah, so we're just saying that now that we are reaching the maximum value after 3 increments after here. So now let's start from there and keep decrementing until we reach the minimum. That's what we're doing. Yeah. Of course, if you just want, or you can say maybe I will be equal to 0 and go all the way to maximum. You can do that as well. That can also ensure 3 iterations. But you're writing that in a way that's more corresponding to what the current value is for the counter. Yeah. All right, any question about this? All right, if no, I think that's about the end of this particular JUnit's lecture. And I think it's a very practical lecture about how you can set up the test cases. And you may have to use them in your lab number 2 and future labs as well. So you can also get a chance to practice. So yeah, I do have some exercises for you. You should really try to create more test cases. Remember, we only covered 3 cases in the lecture. There are another 5, right? I would suggest try this, download the source code, import it to your Eclipse, and try to program another 5 test cases. That'll be a very good exercise for you. And some further reference, if you want to find out more about JUnits, feel free. But I think what we cover in the lecture and the tutorial, they're good enough for this course. If you want to explore further, be my guest. Okay, if no question here, why don't we take a short break by taking attendance? And then we'll talk about a new topic. Yeah, please have your mobile device ready. I'm going to pause the recording now. All right, so the next lecture we're going to do is something called object equality, right? So I'm hoping to get most of it done before the reading week, so you can also try to apply it from your lab number 3 only. But it's going to be released sometime in the reading week. So let's now get through the lecture. It's a very interesting one and very useful. Whenever you talk about OOP, you have to talk about equality, which you kind of avoided in the review lecture. That'll be a little bit too much for the OOP review. Let's now do it properly. All right, so what should we learn about the equality? And the keyword over here is something called override. So override is really like a very special Java term. Think about override simply means redefine. Do you want to redefine something? Define something to be something else. Redefine. Like it's override as well. Object equality is tricky because sometimes the equals method may be overridden, but sometimes the equals method may not be overridden. So you want to be clear about which case it is. And we're going to see how we can use the JUnit assertions for Java for the object equality. Either assert the same versus assert equals. We're going to see the exact difference between these two. Right? So they're different. We'll get there. And we're also going to review a little bit about the short circuit evaluation, the ampersand, and OR. I'm pretty sure you guys have seen this, but I would love to review that a bit because you need this kind of knowledge over here and insight in order to understand some critical implementation for the equality. All right, we need that too. And also we're going to see when we talk about equality, it would be pretty easy and straightforward if your class has no array attributes. But once we start introducing array attributes, like in all your labs and tutorial, how should we deal with it? It's not too bad, but you just got to write a little bit more code and more careful tracing when necessary. Right? That's something we'll see. I'm hoping to get through some introductory lesson here and really let you see why object equality is so important and so to understand. And then we'll see how far we can go. We'll see. All right, let's start from something very basic here. Give me just one moment. Okay, here. So the first slide here, I want to go through quickly. Okay, let's recall from the review. So we got a primitive variable, in which case, let's say you got some double 7.5, 7.5 over here, like 2 different boxes holding 7.5. And a reference variable, on the other hand, they store only the address for some object, right? I don't need to visualize that anymore. You guys are pretty good in that. So for example, if I got P1, will be a new point, and you will store the address. I also got P2, that'll be another new keyword, right? Now, equals operator, that's something we want to be clear. You can use the equals operator on both primitive value and the reference value, but they compare something a little bit different, right? So primitive, if you just compare equals, compare 2 doubles, just compare the values directly. That one's easy. But what about if I say 2 reference variable? We also know pretty well, compare the addresses, right? That's what we did for your written test number 1. Right? So far, so good. All right? So what we need to understand is about there's something further we can compare different reference type variable. For example, let's say I got 2 persons over here. Maybe I want to compare their maybe income. I want to compare their social status. I want to compare their maybe names, etc. It could be just beyond their addresses. I know they're different persons, but do they share anything in common as 2 distinct persons? That's really the motivation here. All right, so now this is something I would like to do, but before that, I would like to give you some quick demo. All right, let's now take a look at the source code. I'll also make it available to you today, but we want to see something right away. Now, let's now say we have version number 1, so point v1, point class version 1. Okay, pretty simple class. Let's say we got 2 attributes here, x and y, easy. And also we got get x and get y. And also we got constructor. Point v1 will just initialize x and y accordingly. Nothing else. That will be it. All right? Now, let's get right to the point. Let's say I want to have some console output for me to try out, or JUnit test. Let's say JUnit test. If I go to the test points over here, okay, over here, you can see I got point v1 and point v1 as well. I got p1 and p2. All right? There are 2 different objects. So that should be very easy to see. If I say p1 equals p2 equals, they should be false because they're different objects, right? So that's why assert false should really pass. Similarly, if I say p2 equals p1, doesn't matter. They're different objects, right? Now, I want you to pay attention to these 2 lines over here. All right? So now this might be something new. I say in line number 19, p1 dot equals p2. Did I declare any equals method in my point v1 class? I don't think I did, right? Let's double check. If you go back to the point v1 class, nothing. This is it. No equals method has been defined. However, I'm calling it in the tester. All right, let me write down exactly what we just have seen. It is important for you to see the beginning. So now we got basically the class point v1. And then we got x and y. We also got a point constructor, and that will be it. It is important to say no equals method. Explicitly defined. So it seems a little bit weird because let's see, this will be the class we have. Let's now try to reproduce a little bit of the tester. So what we did was we say point v1, p1, something. And also point v1, p2, something, using new keyword, right? But when we say p1 dot equals p2, number 1, no compilation error. Even though we did not explicitly define that. Isn't that odd? According to what we said in the tutorial, right, in the review, whenever you want to call a method, you better define that. But now we do have some exceptional case here, right? So now we got to embrace this exceptional case because there's some more story to tell over here. So it is not the case that this equals method is never defined. It's just defined somewhere. All right? Let me now prove that to you. The way you can also try to verify this yourself is like this. I'm going to go back to that Java code. Oops. Maybe here. Sorry about that. There we go. Over here. I just place a breakpoint, line number 19. Because not everything compiles, I can now use the debugger. I want to step into this equals method to see which equals method is being called. Because I know that I didn't explicitly define or declare the equals method in the point p1 class. So where does it come from that can make the compilation pass? That's a critical question here. Let's now try to launch the debugger. And then I'm going to switch. Okay, now I'm pausing at line number 19. And I'm going to do step into. That's very critical. If I say step into over here, and notice that there is an equals method is somewhere. Where does it sit? Something called object. All right? So the object class is part of the Java API. It's a very special class. Right? I'm going to explain that in the page, but what I have just demonstrated to you so far is several things. Number one, even without explicitly declaring the equals method in your own class, like a point v1, you can already use it, number one. Number two, the equals method that's being called, once we do the step into, sits in a class called objects. Number three, which we're going to see, if you don't like this version being called, you can override it or redefine it. That's basically all this lecture is about. All right? And one thing to note, if you look at what's being called over here, in the object class, it's going to say, well, if you want to compare 2 points objects, I'm only going to do equals equals. Meaning that by default, it's just going to call the reference comparison, equals equals. All right, so that's a very critical demo I would like you to try. Only take you maybe 30 seconds to really reproduce what I just did. But it's important for you to do so to really understand in the beginning. All right, so here, now I want to add some remark, and then we can go on to do other stuff. So this equals, as I just illustrated to you, is the default version from the so-called object class. One may argue that the name here is a terrible name because you say object at the same time class, right? But that it is what it is, right? It's a class whose name is objects. And then that one there, let me just say a little bit more. When you say P1 dot equals P2, if you recall, did I already? Okay, you can see that's this equals OBJ. OBJ is a parameter, right? If I go back there, so this is the this. And this over here is the OBJ. And according to that default version, it's going to compare this equals OBJ, right? So it boils down into this equals OBJ. What this tells us is follows. For any class you are trying to create on your own, there is always the equals method available to you. And the definition is simply going to compare the reference equality between the context objects and the argument objects. So that's what we have seen. All right, let me now go a little bit deeper here and see what the diagram looks like. If you look at the slides, it does mention something about this. So implicitly, every class, well, this I have to talk a little bit turn about child, subclass, parent class, but it's not heavy. We just need to know, number one, there is a class called the object class in Java. That class is already there. Very simple class that you cannot get away from that. Every class you create on your own is said to be a subclass, meaning that you're going to reuse every method from that particular object class by default. All right? You have no choice. You have to reuse it. It's available to you. And the object class is what? Symmetrically, it's called a parent or super. So let's look at the diagram. All right, so this is how it looks like. So the class is called objects. And the method we just saw is called the equals method. And that one's going to do this equals OBJ, right? That's what we saw. So there are other methods in the object class which you can also look into. But for now, let's only focus on this one here. So this is so-called a default implementation for equality. This one here is said to be the default implementation. Default implementation, which would only do reference equality. And then we have the point v1, in which case we did not explicitly define any equals method. in which case you're simply just going to use this one here. All right? So here, the equals not explicitly declared. In which case, you will just use the default from the object class. On the other hand, as we'll see maybe on Thursday, I still got a few minutes. I can show you one more thing. If I got another class called point v2, version number 2, I am going to explicitly define or declare the equals method, in which case it's going to override or redefine the equals method. So we are not going to use this version anymore. All right? This is the critical difference you want to see. So it really depends on how you structure your class. Okay, so now the equals method overridden, or you can say redefined. In that way, if I try to say some objects of type v2 and call the equals method, it's going to not use this version anymore. It's going to use this version instead, right? So you really want to compare and contrast this guy here and this guy here, right? Let me do one more thing, and then I think that'll be good enough. And what we're going to focus on Thursday is we're going to see the individual lines of implementation for equals method. But you got to give me 2 minutes, all right? I want to show you something that Eclipse will do for you for equals method. Pretty cool. Okay, so I would suggest we go back to the point v1 class. Let's say now, what if we want to override the equals method, right? One option would be you can simply type it out by yourself by say public Boolean equals, whatever. Another way is to have Eclipse generate for you, which I recommend. Okay, let's now take a look. Make sure you put the cursor outside any of the methods and right-click, and then you're going to choose something called source, right? Under the source, there is something called generates. Generate hash code and equals. At the moment, Eclipse will generate both methods, hash code and also the equals at the same time. But we are not going to worry about hash code. Not applicable for this course, right? Choose that option there. And then this one here just to say, if the Eclipse is going to generate the equals method for you, what attributes do you want it to compare? Let's say both attributes, right? Nothing else you need to change. And you got to say generates. This one has been generated for you, and for the hash code, I would suggest you can just delete it. That's okay, just for now. And one thing I want to say, just 1 minute, this is called override. So you can just keep this flag, this tag over here. That's generated for you. And the equals is basically an accessor, which takes a Boolean. And you will take just another object over here. So object class, I'll say a little bit more. Object is the most general template you can ever have in Java, right? I'll say a little bit more next time. And you can see we got one case, second case, third case, and then fourth case. So these are the individual phases that we need to study for the equals method. All right, so that's something I'll do on Thursday. All right, I'll see you tomorrow in the test. Good luck.